Hello folks, Ms. Strong here, and I am back with Unit 3 Homework Demo Video 6. So let's get started. We are going to be working with fractions, decimals, and percents in this homework. We'll be going back and forth between fractions, decimals, and percents. So let's remind you of some of the things that you have learned in the past about these guys. The idea, fraction, over here, 1 out of 100, 1/100th, 1%. What we usually say is that when we go from a decimal to a percent, we move the decimal twice to the right. When we go from a percent to a decimal, we move it back this way twice. Sometimes students have a hard time remembering which way to move it. I have this silly thing called the Dr. Pepper method, so let me show you what that is. Dr. Pepper DT, right? Well, if you have a percent, you need to get it to a decimal, you move it over here to the D. And if you have a decimal, so it's up here and you need a percent, you're going to move it twice that direction. So maybe the Dr. Pepper method will help you. I'll show you a little bit more on the next page. Just wanted to get you familiar with some of these really common percents, like 10% is 1/10. 50% you already know, 1/2. You probably also know that 75%, 0.75, 3/4. These will come in handy if you just kind of know that these are these basic ones. They will be helpful to you in your homework and as you're working with percent. So percent is very much a fraction. Percent means out of 100. So if I say 36%, I'm truly saying 36 out of 100. If I want to know 36% of a number, then I can multiply that number times 36% or times 36 over 100. So when I'm trying to find what's 15% of a number, then I write 15%, and I can write it as a fraction, times whatever number it is I'm trying to get the percent of. And look, I used an X and then a times sign, so that is a times sign. I could also say, well, if I need 15% of a number, then isn't it 0.15 times that number? So, having said that, let's look at this little question down here. The following is always, sometimes, or never true. Well, let's just kind of give an idea of what this says. It says 5% of some number is 5 over 100 times that number. And they want to know, is that always, sometimes, or never true? And I hope that after we have done what we just did, about that, you will know that this is always true, that to find a certain percentage of a number, you will always multiply that number times the either fraction or decimal equivalent of that number. So just to be a little more clear, we could also say it's 0.05 times that number. All of those will give us the same answer. Okay, so let's play around with some. We have lots of fractions, decimals, and percents here, and we want to be able to write the equivalent fraction, decimal, or percent, depending on what we're given. So let me get a different color here, maybe. Nice to meet you. And we'll start off very straightforward. Let's do 60%. Well, if we think about that Dr. Pepper method, I'm going to write that back up here. Well, I have a percent here, right? Well, I have a decimal right here. There's my decimal in 60%. To get it to a decimal, I need to move it back twice. So 60% becomes 0.6, or you can say 0.60. Either one works. But think about it a minute. It's 60 out of 100. So it is 6 over 10 and 6/10. Hope that makes sense. How about 7%? Its decimal is here, and when you try to move it twice, there's nothing there, right? So you have to put in a 0. It becomes 0.07. So 7% is 700, like 7 pennies. 7% of a dollar is 7 cents. Let's try a fraction, and it's one that you are familiar with. I hope you know 3/4 is 0.75. If you don't, throw it in your calculator. How would I write that now as a percentage? Again, I can go back to the Dr. Pepper method, and look, I have a decimal. That means I'm over here with the D, and I need to move it twice to get a percent. So it ends up boom, boom, or 75%. Also, I want to throw out that sometimes you might forget which way to move the decimal, but you might have some benchmarks that you already know, meaning you know 3/4. You know it's 0.75 and 75%, so you might play with that one to help you get to one that you don't know. Let's try this guy, 0.05. I need to think of him as a percent, so I need to move his decimal twice, and that would be 5%. I can also write that as a fraction, and I haven't been doing that all the way through, but it is 5/100. 500. Just from reading the decimal two places, 500. What happens if we have something like this guy and his decimal is not at the end? No big deal. We take it wherever it is, and we have a percent. So remember our Dr. Pepper method, we're moving back towards the D, and we end up with a weird-looking guy, but it's all right. 0.375 is the decimal equivalent. Whoops, I wonder why I wrote a 5 for 5. I was supposed to write 7, wasn't I? There we go. 0.375, and if we need to write it as a fraction, you can think of it as 375,000 because it's 3 places after the decimal, right? This guy's kind of weird. He looks like he is a fraction. I like to think of him as 12.5 or 12.5%. I have a percent. I need to get to a decimal. I start at the P, go back to the D. I end up with 0.125 is my decimal equivalent, or 125 over 100. I also happen to know, and this is just one of the little goofy ones that I remember, 1/8. 1/8 is half of a fourth. So I want to go to a fourth first. Think of this one first. 1/4 is the same as 0.25, and that's 25 cents, right? So also 25%. We could write it that way. Well, 1/8 is half of that. So 1/8 is half of 25 cents, which is 12.5 cents. So 1/8 is 0.125, and that's just how I remember it. It's 12.5 cents, and I hope that helps you remember 1/8. I can also write that as 125 over 1,000, 125,000, and I can write it as a percent. I already know down here, I just did it, went back right to 12.5%. I think I've got to just about all of them, skipped a couple, but I think I got a good representation of all of them. I hope the Dr. Pepper method helps you going back and forth between percent and decimal. And definitely use your calculator when you're trying to get from a fraction to a decimal. That'll help a lot. You just throw it in there. So now we have some word problems that ask us to actually use percent to find some percentage. And we're going to look at this in a couple of different ways. We want to make sure that we recognize that when we're finding percent, that percents work the same as ratios work. So I kind of want to show you that. What is 32% of 80? Well, we can simply do that like we just said. Well, I need 32% of a number, so I need to change it to a decimal, 0.32, and then I need to multiply that by 80. And that's going to tell me what 32% of that number is. Let me go ahead and do that. 0.32 on my calculator times 80. And I get 25.6. So let's read the question and see if that makes sense. What is 32% of 80? Round to the nearest whole number. First of all, I didn't round, did I? But this guy is 6, so he's bigger than 5. If I were going to round this up, I would round it to 20 to the nearest whole number. I would round it to 26. So 26 is about 32% of 80. I also want to just show you this way. We're saying that 32 out of 100 is 32%. So we're asking what out of 80 is that? So in other words, I know it's 32 out of 100, but I don't have 100. All I have is 80. So what out of 80 is 32%? What out of 80 gives me that? And it turns out it's 26. So I just wanted to write that as a proportion to remind you that we're still looking at ratios, fractions, and proportions. two ratios that are equal. So that's how percentage fits into what we've already been doing. Looking at the second one, after a meal costing $32.45, you decide to tip the waiter 18%. How much will you tip the waiter? Round to the nearest cent. So I need to know what is 18% of $23.45. And I'm going to look at that as, again, a ratio. So I'm going to say, well, 18% means 18 out of 100, so I've got my fraction. And I want to know, well, how much out of 23.45 is that? So you say, but Ms. Strong, I know that I'm supposed to just say 18 out of 100 times 23.45, and you would be absolutely right. If you look at this equation, you will see that if we solve it, we would multiply these 23.45 times 18 and then divide by 100, and that would solve for x. That's exactly what's happening here. I know that it looks kind of funny this way, and you might prefer to put into your calculator 0.18 times 23.45, and that's what you do to find your tip in this problem. So I'm trying to decide if I'm going to do it. Yes, I'll do it real quick. 0.18 times 23.45, and I always check, does my answer seem reasonable? I get 4.221. Well, I can't leave $4.22 and a little more, but I can leave a tip of $4.22, which is about what I would probably leave if I were trying to lose 18%, and that seems reasonable. One more. Tax on the meal of $23.45 is now $6.25. How much tax will you pay on the meal? Now we have to be careful to answer the question asked, because sometimes they might ask us, how much is the meal plus the tax? And you need to make sure you're answering what they ask. So I'm going to set one more up. I'm not going to do this one. So 6.25, I can write that as a decimal by popping this back 2 times, right? I have a percent. I can write it as a decimal going back twice, which makes it kind of a weird number. 0.625 times 23.45, which is how much our meal is, and that will tell us what our tax is. Could I have done it as a proportion? Yes. I could have written my best fraction as a, could have written my percent as a fraction, and then multiplied that times 23.45. Either one would do. I'm going to leave this for you to do on your calculator yourself, and go to the next one. Let's see what else they have in store for you. Now we have bought shoes that originally cost $130, but the markdown was 20%, and the tax was 5%. How much was the final cost of the shoes with the tax to the nearest dollar? So now I have to be careful and say, okay, you bought a pair of shoes, they originally cost $130, but they were marked down 20%. So I think I need to say, well, 20%, I need to know what's 20% of 130. And how do we do that? We change it to a decimal, 0.2 or 0.20 of is times 130. So 0.2 times 130, that's going to be, if I push buttons right, 0.2 times 130, 26. So it looks like I'm going to get a discount of $26. So what do I do with the discount? Well, I hope that I take the total original price, $136.30, and I subtract $26 from it. So it looks like $104 is going to be how much they actually cost. That's the cost of the boots. Except now I have to put tax on them, right? And my tax is 5%. So 5%, 0.05 times my cost, so 104 times 0.05 tax tells me I'm going to have to pay $5.20 in tax. All right, so I'm going to pay $104 for the boots. I'm going to pay $5.20 in tax. So it looks like my boots are going to cost $109.20. Not a hard problem, but you have to pay attention to what you're doing. You have to find 20%, subtract that from the cost, then find 5% and add it into tax. So just be careful with what you're finding. You should be fine there. How about a CD player that costs $111.87? Yesterday it went on sale for 23% off. If you bought it now, how much would you pay? Well, I'm going to pay the $187 up, $111.87. I'm going to pay less than that. And how much less? Well, I'm going to pay 23% less. So if I can find 23% of that number, and I can, 111.87 times 0.23 tells me that I am going to get a discount of $25.73. So do I pay $111.87? No, I pay $25.73 less than that. So let me do the subtraction, 111.87. And I think I'm going to pay $86. And it says 13.139, and that's going to round up to 14 cents. So it said 0.1399. And I rounded that up to 14.50. So let's see if I answered the question asked. How much would you pay? I think I'm going to pay $86.14 because I subtracted my discount of $25.73. Not bad, I hope. Ooh, change, percent change. Little bit different than just finding a percent of something. I wrote it here two different ways. Percent change is how much it changed over the original amount times 100. Well, how much it changed is the difference between the first number you get and the next number. So I wrote it both ways. You can think of change as difference, which is subtraction. That's what I usually write. Let's read it and I'll show you what I mean. The attendance last year at TXVA's high school graduation was 853 people. This year, the attendance is predicted to be 1,005 people. What is the percent of increase? And sometimes you're looking for percent of decrease. We'll talk about that in a minute. But when you see percent of increase, you think, I need to take the two numbers and find their difference. So in my case, it's going to be 1,005 minus 853. Once I do that subtraction, I will divide by the original amount, which in this case is 853, and then multiply by 100. So it looks like a lot, but it's not too bad. Let's do the subtraction first. 1005 minus 853 tells me that the change was 152. So I'm just going to back up to that again and remind you, look, the difference means subtract the two numbers, and that is the same as how much did it change? Well, it changed by 152. Then we divide that by the original amount, which is 153, and then when we multiply by 100, we're really just changing it to a percent. So 152 divided by 853, and then I'm going to multiply that by 100, and it tells me that it is 17.819% change. Did it tell me how to write it? No, so I think I'll round it to the nearest tenth. Whoops, I meant that to be a percent sign. So I'll say 17.8%. So it went up by about 17.8%, our attendance, graduation attendance. Let's try one more like that. Percent increase. This one is percent decrease. Just a tad different. You'll see how it works out a little different. A burger contains 250 grams of fat, whereas salad with dressing is only 100 grams of fat. So what is the percent of decrease in the number of grams of fat if you choose the salad rather than the hamburger? Again, we're going to look at what's changing, and we're going to think of that as the difference. How much did it change? What's the difference between where it started or what's the difference between the two values that you have? Let's just put it that way. Sometimes we start or sometimes we look backwards. It doesn't matter. Okay, so 225 minus 100. Those are the two that we're looking at the difference of. And then we want to divide by the original amount. And we're looking at a percent decrease in grams. So the original amount is the higher amount, 225. and then I always multiply by 100 at the end to get my percentage. 225 minus 100, that's easy enough. That's 125 divided by 225 times 100. Again, why did I divide by 225? Because that was my original amount up here. Now I'm just doing the math. 125 divided by 225 and times 100 tells me that that is a 55.55 or 6, because it keeps going on 5% decrease in fat. So it's less than, if you think about it, it makes sense. It's less than half the fat. The amount of fat that you ingested went down by over 50% because 100 is more than half or less than half of the fat. Kind of cool, huh? I think you're good. I think you can go from a percent to a decimal to a fraction. I hope you can. And I hope you can find the percent of a number by multiplying and change in percent by using the little formula where you subtract, divide by the original amount, multiply by 100. Okay, go do your homework. See you soon.